Um, I'm finally getting to yours. Yours is my fourth video of the afternoon, so it's 2:30. I'm got a little bit of time left for you. Uh, so I'm going to go through as many of the difficult ones as I see. So let's get started. Crap, I don't have colors. Yuck. Sorry. Where would it be? Where is it? No. Colors. There they are. All right. So I just need some bright colors to write for you. Here we go. Let's try this bad boy. Write the following in exponential form. So I'm going to take the most difficult one here, right? Yeah, let's do that. Okay, so I would say we take our base, our log base, and make that our base. So that's 1/2. And then we would say to the third power is equal to 1/8. Right? Not so difficult. Actually, quite easy if you think about it. Again, this would be 7 to the first power equals 7. And really all we're doing is going back and forth between our argument and our power. And so 3 to the fourth power is 81. I just said I would do the difficult one, and I did them all. See how evil I am. Okay. Write these bad boys in logarithmic form, and this is the one that Connor didn't like because we had the negative power, but all we're doing is this base, and this base become our log base. So this would be, I'm going to write it above, log base 8 of 64 is 2. This would be common log, because it's log base 10 of 10,000. Thanks for correcting me earlier, my young friend. Bonus points in your future. Is 3. And lastly, this is the one that we didn't like. Log base 4 of 1/16, and that's our reciprocal. So all reciprocals are negative exponents. That's all. All right, so we'll move on. Solving these was relatively simple. I said go ahead and just write it in exponential form, and we'd say that 5 to some power equals 25. Well, we know that in our heads, right? 5 squared, so y would have to equal 2. Same thing holds true here. 5 to what power equals 1? Well, anything to the 0 power equals 1. All right, I put that in there on purpose. I'm definitely going to give you something that looks like this second one on your test. Let's move on. Just got to get myself to my other layers. Is that it? Oh, good. I'm almost done. Oh, I took that one off. Cool. All right, well, we really are almost done. Here we go. Evaluate these bad boys. And so you could do the same thing with these. These are dreadfully easy. You could actually write them in exponential form. You could say that 3 to some unknown power, give it a variable if you want, is 1. Well, we know that x is 0. Oh no, that's the test question. Oh well, that's the way it goes. All right, so we would say that 4 to some power x is going to be equal to 4. And any time you see the same thing, that power has to be 1, so x has to be 1. Super simple, not difficult stuff. You can also use a calculator for it, but yeah, why? Okay, so there are two types of equations we're going to use, right? We're going to try and get rid of our log by raising it by that power. Okay, so this log base 10, or common log, of 3x minus 2 is going to be equal to 2. And what we said was, oh, well, we'll just raise this to the power of 10. Power. And 10 log base 10, or common log, that equals 1. So what we have left is 3x minus 2 equals 100. We're going to add 2 to both sides, so 3x equals 102. And we figured out that when we divide 102 by 3, we get 34. And then let's do the next one. And this was the one that I showed you where I want 1 log on each side. And that's what I didn't tell you. If I have multiple logs on this side, yes, we could raise them. But it doesn't really work like that because of this addition. So I want 1 log on each side, and here's how it's going to work. I can condense this to show the multiplication. So what I'm going to do is condense log x plus log x minus 1 into 1 common log with an x times x minus 1. And that's going to be equal to common log 4x. And then we raise both, right? We raise both of them. Exponentiate, as it were. So that gets rid of that, and that gets rid of that. And then we just solve x squared minus x, because I went ahead and distributed on my own, equals 4x. I subtract it, so I get x squared minus 5x equals 0. And I factor out an x and an x minus 5 equals 0. And so my x's are 0 and 5. And if you put this in here, you know, does it work? Yeah, well, it does work if I put it right back in here. So that, my young friends, is it. I won't put anything dreadfully difficult on this. And of course, I told you before that the equations themselves, because we have a short class period, I'm only going to put 1 or 2 in there, and they will be simple. I don't even know if we're going to have one where we have to condense first. I might just make it super simple. I mean, why not? As long as you understand the idea of it, let's just move on. Thank you for your time. Bye, guys.